Let's take a look at another example. So here I've got 5x minus x squared divided by that quadratic. All right, well, let's see if we can factor. Well, I look, and by the way, I'm going to do this as I would actually do this for real. I'm not going to like pretend, okay? So you're going to watch me, do it. I see a common factor of x here. So I'm going to factor out an x on the top. And when I do that, I see a 5 minus an x. And you can check that by distributing the x back and making sure I see 5x minus x times x is x squared. This looks good. And then I'm going to divide this, and let's see if I can factor that denominator. Well, I'm going to put an x here and x here. I see a negative sign in this spot. That means I'm going to have opposite signs here. I need a product of negative 20, and when I subtract, I get a negative 1. So 5 and 4 sound good. I want to make it negative, so I'll put the bigger one here, 5 and 4. Check it out, x squared. Outside term minus 5x, inside term 4x. That's negative x, which is good, and then negative 20. Perfect. Okay. It's so tempting to want to cancel these two factors. Don't they look the same? They so look the same. But they're not the same, and we got to be careful. This is x minus 5, and this is 5 minus x. Now, if there were a plus sign here, these are the same thing, because addition is commutative. A plus b is the same thing as b plus a. But subtraction, as you know, makes a big difference. Do I take 5 minus 3 or 3 minus 5? I get different answers. They'll be off by a negative sign. That's a clue that I should actually do something special. I should actually factor out a negative sign. So let me factor out a negative 1 from here. If I do that, all that really means, by the way, just between us, is you change all the signs. If I factor out a negative here, what I see here is this is going to become a negative 5, and that's going to become a plus x. Check it out for yourself. Take the negative 1 and distribute. It changes the sign, it changes the sign, I get back to here. It's still over that same bottom. And maybe to show detail, let me do one more step here. So I've got the negative 1 times x, and here let me just rewrite this, because since it is an addition, I can write it any order I want. So I'll write x minus 5. And now we can see that I have a common factor in the numerator and denominator of x minus 5. It's a common factor, so I can cancel, simplify. And so what am I left with? I'm left with just the numerator of negative x, negative 1 times x, which is negative x, divided by x plus 4. However, there are values that aren't allowed. And what are the values? X cannot equal what number?
So don't forget here, girls, to write the expression is undefined when x is equal to negative 4 and 5. Although I cancelled x minus 5, but I will write its value. So the expression is undefined when x is equal to negative 4 and 5.
Well, we can see that the denominator here can't be 0, so therefore x cannot equal negative 4. But what else? Remember, the original one had this factor, and that can't be 0 either. So x can't equal 5, because that's when x minus 5 equals 0. Now you might say, now wait a minute, this is crazy, because I can plug in 5 into here, nothing goes wrong. That's true. But if you want that to actually equal the original thing, notice that you can't plug in 5 down here, because then you get a 0 in the denominator. So to make sure this really is an equality, we have to actually not permit either of these values, negative 4 or 5. Now, we can actually check our answer by actually putting this into a calculator, typing this expression to a calculator, and creating a table, different values of x, and then we can actually see what this expression will yield. And if we do that, let's just check it out. I'll put it up here. Now notice something interesting. You see that thing that's interesting? Look what happens. See, you are actually smarter than a graphing calculator, which is not a big piece of news, but you should feel really proud about that. Look what happens when the graphing calculator, look under when you see in the first table, we're at negative 4. Look what happens. It gives us an error. And look what happens at 5. It gives us an error. Why? Because you can't plug in this into this expression, -4 and 5. So you can actually absolutely see that when you look at this value, they actually correspond. They actually are equal. You can see it right there. Pretty cool.
Okay, girls, we're done from our lesson today. We're going to complete our lesson tomorrow. See you tomorrow. Thank you.